Hi, everybody. So glad that you're here. Grab your notebook, pencil, and paper. There's definitely going to be some notes that you're going to want to take, and we'll get started in a few seconds. Hey, everybody. Thank you so much for joining me today. I am so sorry that I am not in school with you today. I will be, God willing, with you tomorrow. But this video here, this quick video, is not to supplement us learning anything in class, but it is to just provide a little bit more guidance. So let's just jump right into it, talking about functions. Okay. And when we think about functions in terms of mathematics and what we're going to be studying, you think about there's something happening. There's an input, and when you put something in, something comes out. So if you were to look at this little puzzle here, what would you say the function is? When I input hello, I get out P. When I input rosebud, I get an output of E. When I input breathe, right, I get F. What do you notice here? Feel free to stop the video because right, I just want to keep rolling in case you want to answer some things that I'm to the questions that I'm throwing out. So the function here would be that the output is the next letter in the alphabet following the last letter of whatever the word is. So as you look at the word hello, O is the last letter, and the next letter in the alphabet would be P. You see rosebud, D, E, and you can see what's happening with breathe and happy. Okay, so what is a function? A function is every output has one and only one output. You should write that down somewhere. That is a function. Every output has one and only one output. It's just that simple. So let's look at some different versions of it. Would you consider this a function, right? If it has one input and one output, would you consider that a function? And the answer is yes, you would, because each person has their own unique output. I'm a big fan of what Jonah watches. Would this be considered a function? The answer is yes, right? Every input has a unique output. And even though you can see here that -3 shows up as someone's output, that's all right. That doesn't mean, right? Every time I put in -3, I would only get out 5. So even though there's just this coincidence right here with the 2's as well, it is just a coincidence. So let's look on the one on the left and ask yourself, which one's the function? Okay. If you're not sure, I mean, well, are two people allowed to like the same kinds of things? So the one on your left would definitely be a function. This is definitely a function. The reason why this one on the right is not a function, right? Because we should not have two different outputs. I like to use the example of birthdays, right? I can have, if we were all together, is it possible, theoretically, that we all could share the same birthday? Yes. But I can't have 4 birthdays. I got one. Now, even though some people like to celebrate differently, right? They like to celebrate for the month, but we only really have one birthday. See the opposites there? Okay. So the one on the left is a function, the one on the right is not. Ooh. Now let's talk about this, right? We're looking at this set, and each in this set you have ordered pairs, right? Remember X and Y, ordered pairs, X point, X coordinate, Y coordinate, X coordinate, Y coordinate, X coordinate, Y coordinate, right? So all the inputs, now look at all the outputs. Would this be a function? The answer is no, because, right, when you input 5, you're supposed to get 7. Later down the line, you input 5 and get 0. No bueno. This is not a function. Okay. Would this be a function? And this is easy. We use what's called the vertical line test. You should write that down. The vertical line test is nothing more than taking something that is completely up and down. And if you look, right, you can look at these lines here. And how many times do these lines, if, you know, I would use a pencil or a ruler if I had it in front of me. And I'll show you what I mean in a second. But when I put that pencil down anywhere on that map, it will only touch that graph one time. So that would make it a function. let me kind of switch gears here. Or actually, I think this is the right screen. So if I was doing this on paper, right, here's my graph in green. And if I put down my pen or pencil to test my vertical line test, right, any point on this graph where I move, this graph only interacts with my pencil or my vertical line tester once. So it is a function. Look at this, right? Here's another graph we've seen before. If I put my line anywhere, my tester anywhere on this line, it only hits it once. Check this out though. Look at this graph. You see how it is going to hit that pencil more than once in two different places? That means graphically, this is not a function. So this is a way for us to test whether or not things are functions when we look at something graphically. Okay. One more. Is this a function? It is, right? Because people can have the same birthday. It happens. This is a different kind of graph, but is it a function? Hopefully you went with no. It's not, and you can see why. So domain and range. Let's write this down, and then we're going to wrap this up very, very quickly. Domain and range. Domain means for every input for the function. And then range, should write this down somewhere, every possible output for the function. So if I was talking in terms of my x's and my y's, domain, all of my inputs, right? Think about writing that in a set, or all of my x coordinates. And if I was thinking about range, all of my possible outputs, or all of my y values. So we think about domain being like, what is the range of values? What's my range of inputs? Sorry, I need to stop doing that. For a domain, we're thinking about what are all of my inputs that I could have. For my range, I'm thinking about all of the outputs that I could have. So I'm thinking about that. Here it comes, interval. Oh. So let's talk about that. If I was looking at this graph, and I wanted to look, and we'll wrap up here, and I wanted to say, hey, and I'll use a D for this. What is the domain? All of the x values. And all I'm saying is, right, this is our x axis, this is our y axis, and as this keeps going, right, I continue to get greater on my x coordinate, right? As this keeps going in that direction, it keeps getting more and more and more and more and more higher. And the same thing if I keep looking at my x, right? If I went to here and go down, I have a point. It's going to keep going. So in terms of that domain, the domain of all my x values goes from negative infinity to infinity. Because it just keeps going. It just keeps going that way. And same thing for my y, right? For the range. Even though this is going on a diagonal, it's still going up, right? It's still getting more and more positive. So it's still going up. And same thing on this way. It's still going down. So in terms of all of the outputs that I could have, you guessed it, negative infinity to infinity. Almost done here. 1 minute. Let's take something else that looks a little different, right? Let's think about that domain again. All the x values. We're seeing this graph kind of grow like this. It's kind of growing like a really wide U. And just ask yourself, on my x-axis, does it keep going? It does. It keeps going that way. And it keeps growing that way. So again, negative infinity to infinity. Here's where it gets a little different. Think about your y values. Where is it starting? There's no negatives in the y, so it starts at 0 and just keeps growing up. So your range here would be, check it out, hard bracket 0 to infinity. Because for the y values, it's only right here, right? Y is 0 right here, and it only goes that way. One more. Check this one out, though. Okay. Let's look at the domain here, right? X-axis, y-axis. The domain here. for x. See how I have no parts of the graph in the negative for negative x values? So it starts at 0. So 0 to infinity for the x. And for the y, right, it keeps going that way and it keeps going down that way, even though there's a slight curve to it. That's right, negative infinity to infinity. And that's how you figure out your range of values. So if I wanted to go back and say, hey, let's go to, I think this is the one that I want. Say we go back to this one. Very quickly to wrap this up. If I said, give me, right, you see where it says domain? If I said, give me the domain of this, your x inputs, your x values are your inputs, right? You would put D4 and C2 over here. And if I said your range, you see what your range is. If I said, what's my domain of this set, domain, you would give me 5, 1, and 10. You don't need to give me the second 5, right? Because it's already there. Now, even though this is not a function, there's still domain values. And what's the range? Your range would be 7, 2, 0, and -6. Okay? So that's where I'm going to wrap it up, friends. That should get us where we need to go. Don't forget to keep these definitions of vocabulary and terms in your notebook. Check out homework 7 and 8. Give it a tackle. Let's see what it looks like, and we will pick it up tomorrow. Thank you so much. I appreciate your time and your effort, and I will see you again soon. Thanks for stopping by.